So first thing first, we have to run import numpy as np. Make sure that you run that line of code. Okay, so now the last thing we talked about was universal functions. Okay, and I just want to do this again. So when we're talking about universal functions, and NumPy will iterate through the entire array and perform the operation. So you don't have to do a for loop or anything like that, like you would in base Python. Okay. So we're going to look at scalar operations or unary operations, and then operations between binary operations, okay, unary and binary. So unary operation would be that you have one array and then you apply some function to that array, okay, like for example absolute value. So you do np, so these are all NumPy functions, so you have to start with np dot and then the name of the function, okay. Or sometimes if you put the nd array first and then dot the function name, the function will understand that to be associated, since it is associated with nd array, then it will use the NumPy function. In any case, so the unary functions are ones where the operation is performed within one array, one nd array. So you will go through, so ABS will go through the array, and wherever you have negative values, it will be changed to positive values. And you'll get back integer if it is ABS, and if you have FABS, and you get back floating point values. Okay. The value will be the same, but the data type will be floating point. So SQRT is equivalent to star 0.5. So this is much more efficient. So you need to use, don't use that like what we did previously when we did not have NP functions. We had to use well, you still have to use this if you're using lists and tuples, but when you're talking about data, we'll usually have it as an NP array, or we will have a pandas array. We will talk about pandas later on. So when you have an ND array, you should use SQRT to find square root, then square. When EXP is exponential, so log 10. So this is log to the base E, this is logarithm to the base 10, and then base 2, and so on. Then sine will be, you'll have positive 1 for all the positive numbers and negative 1 for all the negative numbers. So that's what sine will give you. So compute sine of each element, 1 for positive, 0 for 0, or minus 1 for negative values. Now ceiling would be round up to the next integer. Floor would be round down, okay, irrespective of the decimal value. Okay, floor will always, if you have like 5.01, it will be rounded up to 6, irrespective of the decimal value. And same way, floor will take you down to the highest integer value possible. So that's floor. And then RINT or INT would be the regular rounding rule of 0.5. So round elements to the nearest integer. So that's your 0.5 threshold. And then you have mod F. Okay, so you'll get two arrays, the fractional part and the integral part. of each number by the modulus that you specify. And is NaN will give you whether a number is regular number or it is a missing value. So returns Boolean. So you're going to get 0 or 1 for is NaN. Okay. You'll have a one not a number would be 1. Okay. And then you have is infinite. Okay. There are some trigonometric functions that we don't have to worry about. So, and this is what we did last time. So we use an example array. So here we use RANDN. So that's our normal distribution. So you're going to get positives and negatives. Okay. And if you use the ABS function, so you're going to get all absolute value. Square will square all the values. Square root, of course, when you have square root, negatives will not have square root value, so it will be returned as not a valid number, NaN. So you will get a warning that some of the values encountered some problem. Okay. So on. And then we did, and here we took the absolute value and then did the square root here. And round up all values, ceiling. Round down all values is floor. And regular rounding is RINT. And then we have mod F gives you two arrays. Okay. So one is the decimal part, and the other one is the integral part.